potential question is, how do I apply the properties of integer exponents? Remember, the exponent is going to tell you how many times the base is a factor, and your base number is going to be the larger number, and it's going to be your factor, the number you multiply. An example right here is 2 cubed. The 2 is your base number, and the exponent's the 3. So the exponent tells you to multiply 2 by itself 3 times. If I'm dealing with, which we'll see, a few variables, if I'm dealing with something like x to the 5th power, then that means that my base number is x. I don't know what x is worth, but I do know that I have to multiply it by itself 5 times. Alright, we're going to look at product of powers first, so the middle part of your foldable on the left side. And the rule for product of powers is when you multiply the same bases, you're going to simplify by adding all of the exponents. Let's look and see what that means. The first example is 4 to the 5th power times 4 to the 3rd power. 4 to the 5th power means 4 is my base being multiplied by itself 5 times. 4 to the 3rd power means 4 is also my base, same bases, and it's being multiplied by itself 3 times. And if I count up how many times 4 is being multiplied by itself altogether, I see it's being multiplied by itself 8 times. So how do I use this little property? Well, it says when you multiply same bases, our bases happen to both be 4, you can simplify by adding all of the exponents. So I can add, instead of having to write all of this out, I can add 5 plus 3, and I know it will be 4 to the 8th power. Let's try this next one. Again, look at your bases. Are your bases the same? Yes, they're both negative 6. And the first one would be the same thing as negative 6 times negative 6. I'm just using parentheses around this to show that it's still multiplication. That way I don't think that my negative symbol is a subtraction symbol or anything like that. And then negative 6 to the 4th power, I'm going to have 4 more negative 6's. Altogether, I have 6 of them. So my property says when my bases are the same, they're both negative 6, all I have to do is add my exponent, and I will have the correct simplified exponent. 2 plus 4 is 6, negative 6 to the 6th power. Number 3 has some of the same bases and then some different bases. What part of this is the same? The W part. The part that's not the same would be the coefficient. 8 is the coefficient for the first term, and then a negative 1 is the coefficient for the next one. For this, you actually do have to, since this is a multiplication problem, you actually do need to multiply the 8 and the negative 1 together, and that would give you negative 8. And then, how many W's would I have here? I'd have 4, and I would have 7 more W's for the next part. And we're going to get to the point where you don't actually have to show all of this work. Remember, since this is using that product of powers property, all you have to do is add those exponents together. And so that's going to give me negative 8 times W to the 11th power. The next one, R to the 7th power times R to the 3rd power. Well, my bases are the same. They're both R. I'd have 7 R's, and then I'd have another 3 R's. R to the 10th power. 8x squared y times 8y z squared. What part of this is the same? The x is different. The 8's are the same. The y's are the same. And then there's z that's different. Remember, this only works when you're talking about same bases. So let's see what can we add together here. Let's start with the 8 and the 8. Well, this 8 doesn't have a visible exponent, but it does have one. It's 8 to the first, and this is 8 to the first. 8 to the first and 8 to the first would be the same thing as 8 to the second, and we can simplify that in a minute and make it 64. There's no other x values, so I can go ahead and bring over the x squared. There's a y to the first and another y to the first. 1 plus 1 is 2, y squared. And then there's z squared. No other z's. Now, if you want to see all the work for this, the first part would have been 8, and then x times x, because there's x squared, times y, and then if I look over here, 8, y, z, z, and then combine what's the same together. There's my 8 squared, there's my x squared, my y squared, and my z squared. The last thing that, if you wanted to, you could do for this is you could go ahead and simplify. 8 times 8 is 64. And we can't simplify anything else. Number 6, I can multiply the unlike coefficients together. 10 times 2 is 20. And then I have 3 v's here and 1 v here. So remember, you add those exponents together. V to the 4th power. And then the last one, multiply those unlike coefficients together. Negative 4 times negative 1 is positive 4. And then I have 2 q's here plus 5 q's here. Add those exponents. And I get 4q to the 7th power. So that's just a little sneak peek of product of powers. When you're multiplying the same bases, you're going to add those exponents together for simplification. Now we're going to look at quotient of powers. So still in the middle of your foldable. Go over to the right hand side. And our properties rule is when you're dividing common bases, quotient is the answer of a division problem. When you're dividing common bases, you're going to simplify by subtracting the exponents. Let's see what that actually looks like for a few, and then we'll start doing some shortcuts. If I have x to the 10th power, that means that I'm going to multiply x, which is my base, by itself 10 times. And I'm dividing that by x to the 3rd power, so 3x's. Now, if you think about the fact that variables are numbers, and since all of these are x's, they represent the same number, whatever that is. Maybe it's 5. If this was 5 divided by 5, all I would get is 1. So that means essentially they cancel out. 5 divided by 5 again would be 1 again, and 5 divided by 5 would be 1 again. And I'm left with x to the 7th power. Well, how does this work with your property of quotient of powers? When dividing common bases, simplify by subtracting the exponents. So let's look at this one again. If I subtract my exponents, because my bases are x's, they're the same. If I just subtract the exponents, 10 minus 3 is 7. This was a variable example. Here's one with actual numbers. If I had 4 to the 8th power, that's 8 4s, divided by 4 squared. 4 divided by 4 and 4 divided by 4 cancel each other out. And I'm left with 4 to the 6th power. How can I use my property rule for that? All you got to do is, since the bases are the same, they're both 4s, you subtract your exponents, and that also gives you 4 to the 6th power. Now remember, this is a rule that's used for common bases. If you look at number 3, part of this has common bases and part of this does not. When it doesn't have common bases, you'll go ahead and divide those coefficients. Just like with our product rule, when the bases had unlike coefficients, you went ahead and used multiplication. Right here, you're going to go ahead and use division. 12 divided by 2 is going to give us 6. And then we still have to do simplification for the part with the common bases. I've got 5 W's and 1 W, and the numerator and denominator part cancel out right there, and that leaves me with 6W to the 4th power. Again, you can use your rule by just saying I could do 5 minus 1, and that's going to also give me my 4. Now, number 4 right here, this one's a little bit tricky, and this leads us into something that we'll see pretty soon. If I have 9 Y's, 5, 6, 7, 8, 9, and then I have 14 Y's, I'm still going to cancel out, but when I cancel out, I'm not going to have anything left on my numerator. I'm only going to have stuff left in the denominator. Well, we don't want a denominator of 0. What we're going to do is say that we're left with 1 over y to the 5th power. Well, how does that work? I'm going to have y, and then you're still subtracting using quotient of powers. Y, and then 9 minus 14, that's going to be y to the negative 5th power. And we're not looking at it today, but eventually we're going to look at this negative exponent property, where if you end up with a negative exponent, you can rewrite it using the reciprocal 1 over y to the 5th power. And we'll look at that soon. Alright, let's try number 5. Again, if your coefficients are not the same, you will go ahead and just say 9 divided by 3, and that gives me 3. And then I'm going to subtract the part with the common bases, the c part, subtract those exponents, and I'm going to end up with 3 times c to the 3rd power. Now this last one, these are common bases, and these are common bases. So I'm just going to look at the 3 part first. If I had 4 3's on top and 2 3's on the bottom, when those cancel out, I'm left with 3 squared. Does that make sense? Well, remember my quotient of powers rule says to subtract my exponents, and I do end up with 3 squared. And then I have 9 5, and I have 5 5, well, I went way too far on that, sorry about that. And I'm left with 4 5's. Does that make sense? Well, common bases, my quotient of powers rule says to subtract my exponents, and I do end up with 5 to the 4th power. Now I can put this back together, and my final answer is 3 squared times 5 to the 4th power. So make sure you get your foldable filled out for these 2 parts for the rules of your exponents.